Welcome. Welcome. Okay, more limit examples. Okay, so this is a typical type of problem with square roots. Once you've seen one, you've seen them all. You just got to remember to do the trick. So again, if I try to plug in 0 for h, we immediately see a problem, right? So the square root of, so 1 plus 0 is 1, the square root of 1 is 1. 1 minus 1 over 0, and of course 1 minus 1 is 0. So we get this indeterminate form again, and again, every time you get a 0 over 0, that's indeterminate, and that means that we have to do something. We haven't found the answer, one way or the other. We have to do something, and last time we had to factor, and this time we aren't necessarily going to factor, but we're going to make use of a factoring formula. So before I jump straight in, here's what we're going to use. We're going to use this, the difference in two squares. A squared minus b squared is a plus b multiplied by a minus b. This is what we're going to use. Notice here in the expression on top, our numerator, we have something minus something. So in other words, following this form, a is like the square root of 1 plus h, and b is like 1. So, basically, what I'm trying to, so, look, a plus b. No, I'm sorry, not a plus b. A minus b is what I meant to do. Let me erase that. A minus b. A minus b equals the square root of 1 plus h and then minus 1. And that's exactly what we have in our expression. So what we're going to do is we're going to take this and multiply both sides by a plus b. And we're going to see what happens. So if I take this and multiply here by the square root of 1 plus h plus 1, then let's see what a plus b times a minus b equals. And it's going to be this. It's going to be this. Okay? So you can apply the formula and save a lot of time. But I'm trying to appeal to everybody. So if you're not with me 100%, just do the algebra. Just do the algebra. Look. This times this, it's the square root times the square root with the same thing on the inside. So we're just going to get 1 plus h. Not the same green, but who cares? And then we're going to do the square root times the 1, right? So plus, and then square root times the 1 is just the square root. Then the negative times the square root, that's going to be minus the square root. And then minus 1 times positive 1 is minus 1. Okay, so look what happens. The square roots go away. We have the square root of 1 plus h minus the square root of 1 plus h. That goes away. And all we're left with is 1 plus h minus 1. And look at that. We have 1 minus 1. We just have h left. Okay, this is the strategy. Okay, so I've done sort of some background algebra here. We're going to use this idea in our purple limit problem, okay? So we're going to multiply by a plus b, but be very careful because we can't just multiply by a plus b. We can only multiply the limit expression by 1, okay? And we already know what this result's going to be. Stay with me here. Let me go back to my purple. So again, I want to use what I just laid out. So please make sure you understand what I did there with that multiplication. Yeah, minus 1 over h. Now, again, we can multiply by a plus b, but we have to multiply top and bottom. Okay? So I'm going to multiply top and bottom by the square root of 1 plus h plus 1 over the square, over the same thing. I can only multiply by 1. This changes nothing except how the thing looks. Okay? Now, we've already done this. We've already done the hard part. We did the square root minus times the square root plus, and we got h. So we know the top here is just going to be h after we simplify everything, as we just did it a little bit ago. And the bottom, I'm just going to write like this. H times, and then the square root, and then plus 1. By the way, this is called the real conjugate, just for vocabulary's sake. This is called the real conjugate. Also called the algebraic conjugate, just so you know. Anyway, now look what happens, right? Look at the h's. We have an h on top and h on bottom. This is h times 1, so be careful. Don't just send the denominator up top, like I see a bunch of students do. H's go away. Okay? So, we have limit as h approaches 0. 1 over, and then the conjugate. Square root 1 plus h plus 1. Now, if I attempt to plug in h equals 0, that's the whole thing, right? If I attempt to plug that in now, I canceled that problematic h. Like when we did this, we did something big. Because now, my answer, square root of 1 is 1, 1 plus 1 is 2. So, there we go. There's the limit, 1/2. Okay? So again, if you see a square root plus something or minus something, and you wind up with this indeterminate form over here, you should always think about using the conjugate, just like I did here. Think about what the conjugate is. Multiply the top and bottom by the conjugate. Do the multiplication. Cancel some stuff. Cancel that h. Plug it in. You're good to go. All right. Okay. Let's see if we can do another one here. Let's see. This one looks interesting. There's a lot of limit problems where a lot of times you just have to do a little bit of algebra, right? So let's do this one. Limit t approaches 0. 1 over t plus 1 over t squared plus t. Okay. These are two rational functions being added together with different denominators. So we need a common denominator. Before we do that, though, just to be as efficient as possible, even though it might take an extra step, I'm gonna factor the denominator of term 2. So this will make the addition process easier. So I can factor a t, leaving t plus 1. Now I have a common factor. So again, my LCD, my least common denominator, will be easier to do math with. So now our LCD is just going to be, so here's a t. Here's a t, they both contain a t. But then one factor is missing, the t plus 1. Okay? So now, just like we've done a million times in pre-cal or AP, we multiply each term by what's missing, right? So 1 over t, it already has the t, but it's missing the t plus 1. So we multiply this one by t plus 1. Again, the t is already down here. So t plus 1 over t plus 1. We can only multiply by 1. Okay? Plus 1 over t times t plus 1. There we go. Denominators are the same. So I can do some algebra now. I can combine the numerators. So I get t plus 1. So yeah, t plus 1 and then plus 1 over the same denominator. One step at a time. Did I miscopy it? Ooh, yeah, I did. I miscopied the problem. Oops. Okay. So this should be a minus. This should be a minus. Oops. So, okay, minus there. Minus there. Minus there. Minus here. Okay, let's fix that, right? Minus, minus, minus. There we go. That's what the problem was supposed to say. And now plus 1 minus 1 goes away. Limit. T approaches 0. T over t times t plus 1. T's go away. And we're left with, okay, and again, don't make that silly mistake. This is t times 1. So t's go away, we have 1 over t plus 1. And if I plug in t equals 0, I get 1 over 0 plus 1, which of course is just 1. So there we go. Okay. I think we'll call this video